Hello and welcome to another NTOP Learn training video. Today we're going to be looking at medical implant latticing. And so for this workflow here, we'll cover a couple of different latticing techniques. Here we have techniques to work on both osseointegration of this medical implant and also a bit of lightweighting. So here we have our file. We've got that starter file that you can start out with as well, so you don't have to worry about building those different implicit bodies, as you can see that are colored here. If you're curious, you can see we've got an imported CAD geometry. By double clicking through here, I can see we have 3 different bodies that we're working with. If you're familiar with the typical CAD to NTOP workflow, typically we're in CAD creating that initial geometry, defining the different design spaces as well, and bringing that into NTOP. So we can see that's mostly done here. I've done some extra work to isolate some edges and regions so that we can actually define a couple more areas within our geometry. So by clicking on these, hitting I to isolate those views, we can see I've got that outer design space. I have our 2 windows, and then I also have solid regions that we want to keep and not touch because perhaps we want to keep these nice features here. Have to keep this solid because maybe those are going to be where we're adding in some threads, things like that. But yeah, we have our 3 different regions. We'll use all of them by the end here. But again, just going through a couple of different latticing techniques. First up, Voronoi latticing, so that we can look at that osseointegration and how really affect how that implant is going to function once it's connecting back into the body. We've got some periodic lattices we'll talk about just for lightweighting this chunk, as you can see right here. And we'll also get into using custom blocks so that we can see how we can automate this workflow, really take advantage of our reusable workflows to find that ideal implant from there. So you already have these 2 sections ready to go in that starter file. We can just start from here. I'm going to go ahead and I'm going to create a new section. So I can click this new section button here. Nice to keep our implant tidy. Nice to keep our workbook nice and tidy and our notebook organized by using sections. So I'm going to go ahead, rename this. Let's call this the inner lattice. And just so we know exactly what we're doing, I'll type Voronoi in there as well. And so perhaps you're starting to get familiar with working in NTOP. I can add in new blocks by using the search bar up here. I can also use the ribbon too. So I'll do a combo of that just as you're continuing to explore and get used to the user interface of NTOP. But what I want is a Voronoi volume lattice. I know I'm filling these 2 windows with a Voronoi. And so if I go over to the stochastic area right here, we see we have a couple of different options that we can work with. But that Voronoi volume lattice is going to be what's going to fill that entire region here. I'll drag that back down to the section that we're working in. And so as we can see, the first thing that it's asking for is seed points. And so because I've done this workflow before, I kind of know which block we want to use from there. But one nice trick that I always like in case I don't quite know where I'm going is I can double click in that input, and then we can see all of the different blocks that work as that input. So I can see, okay, random points in body. That sounds like something that's going to be helpful here because we're filling those implicit bodies. So let me click on the random points in body, and then we have our different inputs to fill from there. So I've got that body. As we know, we want to fill those windows, so I can just drag and drop that input here. Point spacing. So this is going to be how far away those seed points are going to be. I'll just start with 1 millimeter point spacing. We can kind of see what that looks like. As you can see, they're highlighted here. And basically let's go ahead, isolate these 2 views. This is going to be the seeds in which my Voronoi lattice is going to be generated around. So each of these are going to be the middle of one of those Voronoi pockets. And so that looks pretty good for me. If we wanted it to be greater or more spaced out, I could bump that up quite a bit. Or maybe we want it to be even more dense. And you can see how it's affected. But I'll stick with that 1 millimeter point spacing. But what I'm also going to do is I'm going to make this input into a variable. So I'm going to right click, hit make variable. And then as you can see, now I have this variable that's just sitting on my notebook, and it's now living here as this little chip. Maybe you noticed that happened when I pulled the windows over to here. But the reason I'm doing that is because I know that this is going to be something that I'm going to want to play around with when I'm iterating and creating that custom block. So here I have it pulled out, ready to go. I'm actually going to click on this number right here and turn this into a scalar field. Maybe you haven't really gotten into scalar fields just yet, but really I'm doing that so that I know that I can, in the future, variably change this point spacing. So right now we've got the constant 1 millimeter point spacing, but because I see this field icon here, I know that maybe I could use a ramp in the future and drive it. So we've got some sort of variable change there. We'll keep it nice and simple for now with just that 1 millimeter. But by creating that type, then we have the flexibility in the future to use it. So maybe we want to add in a little bit of information here. I can say that this is going to be the approximate pore size of the volume lattice. Actually, in this case, it's going to be the Voronoi lattice. There we go. All right, what next? We have our thickness. So that's going to be the thickness of the lattice beams. I'll go ahead right away, make that a variable. I'm going to specify that this is going to be my inner lattice thickness because I will have two different lattices that we're working with. And let's just go with, how about 0.25 millimeters? And all of this is really going to change based on your lattice size, or in your implant size as well. But this looks good to me. And so now that that blue question mark has now turned gray, we know that it's run. So I'm going to hit this block, hit I to isolate the view. And that lattice might not look exactly like what we're going for, right? Because basically it's taking in the list of points, which is kind of two different clusters of points, and it's creating that volume lattice around those points, as you can see if I pan around here. But we've got some stuff in the middle. Maybe we want to clean that up. We also want to close up that volume too. And the way that we can do this is by adding this optional boundary. By this little icon, we can see that it's asking for a mesh. So I'm going to go in here, just go mesh from implicit body because I know that I have that implicit window region here. I'm going to drag in that body. Maybe my tolerance just can be 0.1. Doesn't have to be anything too fancy because we're just grabbing onto it so that we can have that outer volume. But right away, you can see our block has run and we've got it nice and enclosed from there. So I'll go ahead, right click, make this a variable. So this is going to be our Voronoi. However, it does have rounded beams on the outside, which maybe that's preferred. Maybe we want to close it, contain it to our window. So I can go one step further, go ahead, look up that trim lattice, where I can bring in that Voronoi. Again, bring in those windows because that's what I'm trimming things to. That 0.1 tolerance works just fine for me as well. And if I hit I to isolate that view, now we can see we've got that flat edge there to make sure it's just within the bound of those windows that we saw before. So let me right click, make this a variable as well. We'll call this our inner lattice. And so if I go ahead, turn on that design space, turn on those solid regions, you can kind of see where we're headed from here. We have those nice windows that allow for that osseointegration. And now we can take it a step further to lightweight our implant even more. Next up, we're going to focus on that lightweighting. So this blue region here, pretty bulky. Maybe we don't need that much material. So we can replace it with a periodic lattice. So I'm going to go ahead, add another section. So this is going to be my outer lattice. And we can call that periodic, just so we know what we're working with. And then if I go back up to my ribbon, we have our different latticing types. I'm just going to go with that periodic lattice. And it's asking for a few different things now. So first up is that unit cell. I could do that double click method. I can also see them up here to have a bit more visual of what I'm looking for. Maybe we want to fill it with a surface-based continuous lattice, so maybe a TPMS structure, could toss a gyroid in there. But I'm going to go ahead and just use a graph unit cell instead. So I can click on this unit cell. We have plenty of different unit cells all built into NTOP that we can play around with. I'm just going to go with a body-centered cubic for now. As you can see, it kind of pops up right in the middle of our implant. Actually, a cute little frame that we have around there, but that's just going to be a preview of the lattice that we're working with, that unit cell. So I can go ahead, bring that into that unit cell input. I'm also going to right click and make this a variable too, because maybe this is something that we'll want to play around with when we're iterating with our custom block in the future. So next up, we need a cell map. I can do that double click method. We'll keep it simple and just go with a rectangular cell map. And we have a couple more inputs to play around with. So first, we're looking for a volume. I can close this since we're kind of done with that workflow for now. And in this case, we want that outer design space, right? We want to be able to fill this volume with this unit cell. Not at that size, but we'll kind of size it down from there. But I can go ahead, drag this into that volume, and then we want to define that cell size. So I'll just start with 1 by 1 by 1. Maybe in the future we'll play around with that. We can kind of see how it's going to fill that region. Let's go ahead, make this a variable too. And then lastly, we have thickness. So again, right click, make that a variable. That's going to be something that I want to play around with. But let's make sure we specify which one this is. So this is going to be our outer lattice thickness. And for that, maybe I'll go a little bit thinner than the last one. Let's just go with 0.3 millimeters. Make sure you're defining your units there, or else it might toss you an error. But if I isolate this view, again, by hitting I, then we see we've kind of overpopulated, once again, that region, just because we're filling that entire cell map with that single unit cell that we saw before. So now we just kind of have this big cube of our lattice structure. I'm going to go ahead and make this a variable nonetheless. We can go ahead and call this our periodic lattice. And then again, we're going to do a trimming operation. So I've got my trim lattice. We can drag the periodic lattice into here. Our domain is going to be that same outer design space. We're keeping our lattice inside. That tolerance of 0.1 works for us. And I can click on this, hit isolate, and then we can see how it's filling up the volume from there. And so we can really play around with a lot of different lattice types. Maybe how this behavior is with the different, how it's trimming at the beams is something of interest to play around with. But we do have it joining back on with that solid region. So some of that behavior is something that's certainly to consider. If I look at the utilities, I have a lot of different filter blocks. So we can filter out open beams, or if they're not connected or floating, things like that. So a lot that we can do. This looks fine for me right now, but perhaps in the future, we've got different ways that we want to manipulate this lattice, have a little bit more control. But for now, I'll go ahead, make this a variable, and we can call this our outer lattice. So as we can see, I've got my outer lattice. I've got my inner lattice. Actually, maybe we want to make this into a different color. So let me go over to the display so you can kind of see the different elements that we're working with. And then I've got my solid region. So those are all the bits that we were playing around with. But right now, technically, they're all separate. We've got 3 different items that we're playing with. So I'm going to go ahead and make a new section. This is going to be called our final geometry. And pretty simple. I'm just going to do one big Boolean union so that we can tie all 3 of our implicits together. You might have noticed I just clicked this plus button here. So I've got 3 different inputs. This implicit body list can be as long as we want. We can just union a whole bunch of things together at once. Very simple and quick operation in NTOP. I'm just going to use 3 for now. So I can drag my outer lattice. I can drag my inner lattice. And lastly, I can drag that solid region down to here. And so as we see, now we're just looking at a single geometry from there, all the same color again. If I wanted to look at that in detail, I'm just working in medium resolution right now. I can click on this, hit Control H for a nice high res render. It'll just take a second to load there. But we can see kind of how everything's adapting, how everything's connecting. If we wanted, we could even add a nice blend radius here. Of course, we'd have to then trim it back to the original space so we're not overpopulating anything. But this kind of looks nice for me right now. So I'm going to go ahead, make that a variable, call this my final implant. So far, we've created that Voronoi lattice in those windows, lightweighted this geometry by adding a periodic lattice in that outer design space, but then also brought back in those solid regions that we were working on before. And so I feel pretty good about this workflow. We've already called out some of these inputs. And so what we can actually do is very quickly turn this into a custom block. Maybe you've done this before. Maybe you haven't played with custom blocks before. But it's very simple and easy to do. So what I'm going to do, because I have my notebook kind of nice and organized already, maybe I'll even close these up to keep things nice and tidy. You can see how simple everything looks. I have 5 inputs that I've made into variables. So what I can do is I can right click, make notebook input, and it pops right into those inputs right there. But everything's also collapsed, so just as easy for me to go ahead and drag these up here. So what we're doing, again, is taking this entire workflow and turning it into a single block. And so these are the 5 different parameters that I want to play around with, right? The point spacing of that Voronoi lattice, the thickness of both the inner and the outer lattice, that unit cell, the cell size of the periodic lattice. I could go ahead and also add comments by clicking on this little comment speech bubble, just to have more clarification over what each of these are doing. So this is going to be the beam thickness of the inner Voronoi lattice. This is going to be the unit cell type of the periodic lattice. Cell size of the periodic lattice. And then beam thickness of the outer periodic lattice. And so these might be things that are very familiar to you right now. You've just gone ahead and built this whole workflow. However, if you want to pass this workflow on to a colleague, maybe someone who isn't as familiar with NTOP, by adding in this context, they're going to know exactly what each inputs, They're going to know exactly what each input does, and how it's going to affect this. Ugh, sorry, let me just start over. If you pass this on to a colleague, they're going to know exactly what each input does and how it's going to affect this implant, especially if they're looking to optimize this implant. The more context that you're providing here, the more control that they're going to have. Maybe even it's the future you as well. And to have this kind of information here is really going to be vital. So these are our 5 inputs that we're playing around with. Of course, we have to tell NTOP what it is we want to output from there, right? Because we've got all of these different blocks, different steps along the way. Could be really anything. But in this case, my final geometry, my final implant, that's what I want to output from my custom block. So I'm going to go ahead, just drag and drop this into the output right there. And so this is looking good for me. I'm going to go ahead and save this. So I'm going to click on these 3 lines up here, File, Save As. I'm saving it in my file directory outside of this window right here. But I'm just going to go ahead and call this my medical implant latticing. And then what we're going to do is actually open up a brand new instance of NTOP. So here we have our new instance of NTOP. I'm going to hit New File. And there are a few different ways that we can bring that custom block into this new instance of NTOP. So I can go ahead, File, Import. I can also check out my imports over here in this left side panel, and I can import a block. Here it's opening up my directory. And I'm going to click on that same medical implant latticing block or NTOP file that we just saved. So here you can see it's importing. And it's actually just running right away. So it's running with those exact same inputs that we had before. So this is what we've already seen. And so very quickly, we can play around with these inputs, and we don't even have to think about what's happening in the background. So maybe let's make this a little bit denser. We could go with 0.5. Therefore, we'd probably have to bump this lattice down to be a little bit thinner as well. I could change this to perhaps a fluorite cell, and maybe I want to make that larger. There are so many different things that we can really play around with, and it's just going to rerun from there. So here, give it a second to render. This is a bit crazy, right? We've got quite a contrast between that outer lattice and that inner lattice, but this is really why we want to be able to test that, play around with things. We could go ahead and actually create a whole bunch of these and be able to very quickly iterate, try different things. Maybe we want to use that hexagonal honeycomb instead, something more face-based. We can open this up. Maybe make this a little bit smaller as well. But really a lot that we can play around with. Here we've got them sitting right on top of each other. But what we can do is very quickly see different examples. Maybe I want to add another one in there too. Probably should have renamed this so it doesn't have that training right on there, but as you can see, we've got those different inputs, different things that we can play around with, have full control, but also be able to hide away some of the other aspects that maybe don't need to be played around with. So as you can see, quick example for how we can make our workflows reusable. From there, we can really start to iterate. Maybe we can start to get into list processing. There's plenty of information on the Learning Center to understand that a bit more, but this is going to help automate that workflow so we can really find that ideal implant. whether it's looking further into that Voronoi for osseointegration or kind of figuring out that right ratio of that periodic lattice for lightweighting as well, but wanting to maintain that structure too. And so again, covered a few different things, getting into the Voronoi lattice, periodic lattices, and also being able to build up that custom block as well. So hopefully you learned something new in this workflow, and looking forward to the next.